Hello, and welcome to part 2 of the dungeon generator. So today we are going to fix up the corners because they weren't spawning correctly, and then we're going to start delving into corridors. So first off, let's go to our generator blueprint. Is it opening for me? Yeah, it's opening silly for me. Okay, there we go. So, what we had previously for spawning our outer corners and spawning our inner corners, so I just have to rename those, was this basic setup just plugged into the select, and then checking. So this here was, gonna open up paint real quick. So it was checking if there's a tile here, is there anything over here? It's corner. Okay. So it was checking the diagonals for the outer corners. Okay. But when there was a tile right beside it, this still has nothing. So it would, even though this should be a straight wall, it was building corner pieces between them. So I just need to add a bit more logic to that. So for our outer corner, so that is spanning a place like this. So it's testing for this missing chunk from a diagonal of this block right here. So if it is forward and to the left, we also need to check if there is a tile forward of it. We want, there is nothing, so tile forward and to the left, not. And we want to make sure there is a tile forward and a tile left of it. Okay, so for the two directions it's checking to get a diagonal, we want the other directions being checked, and then that gives us the proper corner logic for it. So we're just going to move our inner corner way down because we're going to need to do this a few times. And then something similar with our inner corner. Okay, so first outer corner. So I just copied this test relative location. And we want to make sure the diagonal is not, but the two other blocks are. Just like that. So of course I got rid of the not node over here. Okay. Now we'll bring up our next section. We're gonna copy all this. And it should be nice and simple. So we're just going to, for each of these directions, we want 1 on the X, we want 1 on the X, we want 1 on the Y, we want 1 on the Y, and that's that. So these ones are really easy to put together. We just need to put in a few more of our macros, and that goes into option 2. Same thing for this one. We want -1 and 1. Change that to -1 and 1. And last one here. We want -1 and -1. So again, this is checking that there is nothing in the diagonal corner. but there is something here. So what we're checking is, so this would be x equals 1 and y equals 1 right there. We want this as a not. I'm just gonna erase this. Oh, it erases the text too. That's helpful, Paint. Wow. No, I want to erase brush set. Okay. Gonna do new, don't save this. We want our 3 tiles just to visualize this. So again, we want to check in this case x equals 1, y equals 1, no tile. And then x equals 1, yes tile, y equals 1, yes tile. And then if that is true from this reference point, so if this is empty and these are true, we'll draw a corner right here. And then the same thing, we're then just doing for, okay, what about this diagonal corner and this diagonal corner and this diagonal corner? So if we want negative x and 1, get this corner, then we're going to make sure that y1 is true and negative x1 is true. Yeah. And that's what that is doing. And if we plug all those in, and extend our comment box around it, definitely makes it longer, but not really adding that much complexity to it. And I plug things in correctly, which I keep forgetting to do. So I need to plug in our reference vector to each of these nodes. Zoomed out just a little bit too far. There we go. Reference vector and a reference. Compile and save. Does it like me? It does. And now we should see on all of our corners, hey, we've got an outer corner on each of those, and then check for something where it's opposite side. Yeah, we've got outer corners, but we don't have them being spawned all the way across the wall like we did. Okay. Now let's go check our inner corners, because our inner corners were also being spawned all the way across the wall. So what our inner corners need for logic is, instead of having these as an and then making it not, we're going to get rid of that not there, and we want to put our both of these not. Okay, so that's all we're doing there, is we're just moving the ands over and putting nots before them. And that fixes up our inner corners. Just order of operations, doing the nots first. So saying both of these do not exist, continue. Whereas before it was going to say, are both of them existing? And then nodding it. And because of that question being different, it gave us different results. Because then if one of them existed, it would still throw a true over here, whereas we want to make sure that both of them do not exist. Okay, and then one last group. We'll need another knot from up here. And another knot from over here. And if you want to take the easy way out and just get the project files, again, all the project files are available to anybody supporting me on Patreon. So if you head over to patreon.com/ToadNet, you can download these project files. So we should see corner there, and corner there, and corners there. Beautiful. All of our corners are now working, and we aren't getting them duplicated all the way along the wall. Look at that. That's looking good. Oh yeah. So from our player perspective down here, okay, on the end, we've got those nice little corner bits to hide the tubes going into each other, and then these bits, we've got the tubes wrapping around the corners, which make no sense on these columns because you just have tubes infinitely looped into each other. But going down the walls, the tubes continue, and when we start spawning doors, the tubes do go through the doorways. But when it makes a column like this, it's like, yeah, infinite tubage. But that's just a quirk of my tile set here. You can import whatever tiles you want. And you just set the scale of your tile in our map settings or editor tools? Editor tools, scale. You can set the scale of the tiles you're spawning. Okay. But anywho, there goes the easy stuff that we get to get out of the way right away. That's way too many gets and way too many ways. I'm gonna sip some tea and let my brain refresh for a second. Okay. So now that we have the simple stuff out of the way, fixing up our wall spawning, by just taking a step back and looking at the logic again, now we can make corridors. Are you all ready for this nightmare? No, you're not. Nobody's ready for this nightmare, but we're gonna go do it anyway. Okay. The corridors are not difficult. It just means a lot of thinking and testing, like on, not exactly like on the wall spawning, but similar enough, thinking through which directions and where things are relative to each other. So, just gonna pull up my reference here. Okay. So we're gonna do a new function. And this one we're gonna call corridors underscore map corridors. And then we want in our inputs 2 int vectors. And we want room A, and we want room B. Okay. We are then gonna bring that out here. And I need to get the rooms variable. Get rooms. We're going to find room A in our list of rooms, and find room B in our list of rooms, we're also going to break those variables. You're gonna do a break. You will want to put the reroute nodes here because we're gonna collapse this down to make it tidier, and that will leave us just 2 inputs instead of 4 inputs coming in. So you do want these reroute nodes. So this here will be another break vector. And then we're going to copy our 2 break vectors, Control C, Control V, and plug them in off the extents. So remember, our rooms map, okay, so that's the type of variable, is a map. It is twofold. So doing 2 things for us. Sorry, the music's just a little loud and I can't change it on my end because Pretzel's like way out of the way. So I'm just going to, there we go. Okay. So our room map, so this is a type of variable, a map, which is a list of keys. So something to look up something, so a name or a reference, and a value with it. Well, our name is our room's location, the root location, and our value is the furthest extent of our rooms. And that's what we set up yesterday when we made the rooms. And now, yeah. Now we're going to bring this down, and we need to save all the corners of the rooms. Okay, we're not going to care about the Z location because we're only building this on 1 floor. Actually, you know, it doesn't hurt to have the Z location. We're not going to use it, but it doesn't hurt. So we're going to make some variables. So we're going to promote to new local variable. And we want this AX. Now we're going to, on AX, set that category to corners. Just to keep things nice and tidy here. And we're going to start duplicating this. We're going to duplicate, and we want a Y. And we want to duplicate a Z. And duplicate a X2, which will be the far X corner. And duplicate a Y2, the far Y corner. So just getting the root location and the furthest extents away from it on the X and Y. And then exact same thing, we want a BX, a BY, BZ, and the only reason I'm duplicating these here instead of just making them with a promote to local variable is then it keeps it all in my corners category here, and I don't have to go set the category again later. So it's whether you do it out here and then they're all hooked up and you set the category later, or whether you do it in here and then you have to go hook them up all later. Either way, you're dealing with these variables twice. We want BX2, and we want BY2. Okay. So now I'm going to plug this in, and I'm going to pull out from it, and I'm going to do a reroute node. And I'm going to select all this, right click, and collapse node. We're going to call this get corners. Then when we get in here, we want to make sure our execute pin is on the top. And then we're gonna rename our two things to room A and room B, just like that. Okay. This is the other reason why I don't want to set up all those variables first, is for whatever reason, when you collapse the nodes, it would keep a reference to global functions in the blueprint, but it won't, there's global variables, but it will not keep a reference to local variables. So I now have to go through here, replace AX with AX, and it redoes the connection. I'm gonna hold Alt and drag out all my other variables. So I get setters on them. Ooh, holding Alt and dragging apparently zooms you out. That's news to me. And there we go. And now we just have to hook these all up. Loop that one down. And then continue these kind of like stair steps moving down. And then the room root location, which is what we're bringing in, sets our X, Y, and Z. And then our extents are our X2 and our Y2. So just go and plug in all these variables. Then if you grab them like this and hit Q, and same things for the upper ones, Q, straightens them all off. Didn't quite straighten it how I wanted to, because I want it straightened off these pins. So then we get this nice little stair stepping. Because it visually amuses me. Look at that, we're like boop, 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 going down the line. Gonna add a couple reroutes here for cleanliness. Something like that. Straighten that off. And then we can comment this. Get min and max extents of each room representing outside corner. There we go. So now that we have those, we can use it for stuff. We're gonna hit this little back arrow, go back to our function, straighten that off. Get rid of our reroute node now, because we just wanted it to give us an out pin. And now we're gonna start doing some checks. So, do a branch. And our first check is going to be AX, BX. Want the max between them. And we're going to put this together. I'm going to comment it, and then I'm going to go back to Paint and explain how it's actually working. And then we want AX2 and bx2, and we want to get the min value. And then is the max value less than or equal to the min value? And we'll plug that into our branch. And we're going to comment this. Are rooms parallel on X with overlapping sides? Okay. Let's go back to Paint. We're checking our two rooms. Got room 1, and we've got a little lower over here, room 2. Okay. And then, just so we all know how things are happening here, we are talking two-dimensional space, because we're looking at it from the top. And we've got our x-axis moving forward. We've got our y-axis moving sideways. And the arrows are positive. What we're saying here... I'm just gonna make that visible here, and then we're gonna bring up Paint again. Beautiful, look at that. So, the max of AX and BX. So let's map these out. So we've got room A, room B. So AX will be this corner right here is our AX. And then we got BX. We want the maximum value of that. So in this case, it's AX. Then we want the minimum value of AX2, which is up in this corner, and BX2. So what we're checking is the maximum X value, is the maximum root corner value less than or equal to the minimum top corner value. And what that's telling us is if these are overlapping, like right here, we have an overlap because this AX is less than the lower BX2. So these two are overlapping. So they are parallel this way, or parallel, they're running on the x-axis. So they're running side by side and they have an overlapping chunk. So we could then build a corridor right in there. So that's what this is checking, okay? Hopefully that's making sense. Perfect. Then we want to check whether it's to the right or to the left. So to do that, we're just going to say is by greater than ay. Greater than, we don't want a greater than or equal, we just want a greater than to a branch. Gonna comment this. Room B to the right, question mark. And then we're going to make sure they're not merging. So right now, remember, we allow our rooms to merge. So some of them, like these two here, have become one big room. And we can see that if we go to our map settings and turn off merging, these two should split apart. See, they're now two rooms. If we allow them to merge, they come together to make one bigger room. Okay? So we want to make sure that if these rooms are merging, like these two are, that we are not trying to build a corridor there, because that would be silly. We're going to go back to our corridors. So we want to check. Go back down to our corners. We want by minus ay2. Okay, so if we go back to our paint, so by, which we're testing, is this here. So where it is on this axis, so by would be this corner. And we want to make sure that by minus ay2, so A's outer corner, if B is to the right, the distance between these two is greater than 1. Because if it's just 1, that means these two are butted up right beside each other. We want to make sure that distance is great. So by minus ay2 gives us a relative, and we want to say, is that greater than 1? Branch. Now we're going to comment, check that rooms are not merged. Or we could form that like a question. We could just say rooms are not merged, question mark. Okay, and remember we're working on B is to the right. So if B is on the right, we've got an overlap here. We're now going to find out where within this overlap, so between this corner and this corner, where to place our corridor. So we're going to get a random value between those two. So we want AX, BX, max. So same sort of thing we're doing here for checking. And then we want AX2. Oh, phone call. I can ignore that for now. AX2 and BX2 min. And between these values now, and because we've already checked them and made sure that we are overlapping, we are now wanting to get a random value between those. We're going to do a random int in range from stream. Straighten that off. Plug our stream into there. And there we go. And that is going to be our promote to local variable. Out y. Our output that is on our y-axis. Straighten that. Bring it down. And there we go. And then we are going to make an int vector. Okay, so our y-axis this is out x. Rename out x. This is our x, so we're plugging our x in there. Then we need our y and our z. Okay, so we're going to be working room A, then room B. So on room A, we just want AZ. Right there, nice and simple. Just keep it Z the same as it is for the corridor. And then on Y, we need which side of the room we're coming from. So since B is to the right, we want AY2. So we want this side, so AY2 to BY. We want AY2 and then we're going to copy this, paste it, and we are going to do a BY and BZ. And we're going to promote these to local variables. Promote to local variable, point A, and point, promote to local variable, point B. Just like that. Okay. And this here we're going to say make corridor from A to B on X, sorry, on Y axis. These comment names, we're wanting to be very specific with them because it's going to help us building out the next bit. Okay. Sip of tea. And now we take these two bits, so rooms are not merged, and make corridor from A to B. We're going to copy that all. And we're going to paste it all. And we're going to shift select all of our comment boxes here. And turn off bubbles. There we go. That makes that easier to work with. Okay. So now we're going to plug this in. So now we're working on the left. So now that we're working on the left, so we're making sure the rooms are not merged. So if B is on the left, so now if B is over here, if we're switching these two, we're now looking for BY2 and AY. So we want to AY minus BY2. Then this bit stays the same, getting our random x value, except for now, point A is going to be going to AY, and point B, actually, do we switch up? No, we're not going to switch this up. Okay. So point AY, and we want BY2. Point B. And we're going to say this, make a corridor from B to A on y-axis. Okay, remember B's on the left now, A's on the right. Okay? Because when we make the corridor, we're always going to want to work with positive values, just because it makes it a little bit easier to go through. We can make a nice little looping thing to make it work instead of having to do a bunch of testing. But it only works if we're always working positive. So we want to go from B, which is now over here, to A, or A to B, depending on which one's on which side, so that we're always going to the right, because then we can just count up in ones instead of having to do negative ones. Would be a non-issue if the current versions of Unreal Engine didn't inconsistently round vectors. But, hey, what you gonna do? So, we've got rooms are parallel on the X. Now we're gonna copy all of this. Control C, Control V, move it down here. Come off of the faults of overlapping on the X in here. And rooms parallel on y-axes. And now we want to do the same thing. We want AY, BY, AY2, and BY2. Just like that. And then instead of checking if B is to the right, we're going to check if B is forward. So is it in front? And we're going to check that by getting BX is greater than AX. Okay. We're only continuing if the rooms are not merged, so if B is forward. So we're now dealing with this. So instead of them being side to side, being forward and back on the x-axis, and we're going to deal with B being forward first. So we've got room B and room A. So only if it's forward, so we need BX, so it's bottom side. Okay, so let's just do some labels. So we've got BX, BY is in that corner. Then we've got BY2, BX2, there we go. And then same thing over here. AX2, AX, AY, AY2. We want to make sure that this area is greater, so we want BX minus AX2 to just get which one that there is distance on the X vector. x-axis, yeah. Sorry, what did I just say? I said b is forward, so we want bx minus ax2. And then if b is on the bottom, we'll want ax versus bx2. For our lower one. That's just checking that our rooms are not merged. Okay. So if b is forward, we're going to be moving positive on the x-axis. So moving forward, so we're still going from a to b. Except for now we're going on the x-axis. We want to switch out these max and min values, same as we did over here. So we want the x's to y's. So just a nice simple replace. Ax becomes ay, bx by, ay2, and by2. Okay, make this easier. We're gonna flip that out and do that. Yay! We're then going to right click on our local out x, duplicate, and we're going to say out y. We're going to right click on our x here then and replace with out y. Okay. So point A, if A is to the back, then we want out y into the y. And we want ax2 as its leading edge. And that means we want bx, this is moving from ax2 to bx, and plug in again out. There we go. Oh. Sorry, just gonna stretch a bit here. Down the rest of my now cold tea. Ugh. Okay. Now if A is forward, we're gonna replace our Y's right away. And then we want, so A is forward, so we want AY, or sorry, AX instead of AX2. And then we want bx2 on point B. Okay. And again, we want to change this to x-axis. We're going from A to B, and then from B to A, because B is behind and A is forward. We're also going to just drop that down like that, so we can get rid of that. There we go. And this doesn't actually do anything yet. So, what we're gonna do now, I think, is we're going to make a macro, or do I want to make a function? I want to make a function. So I want a new function. Corridor underscore make underscore y. And in here we are going to get two inputs. both of them being int vectors, and we want from and to. We're not putting A and B here because we don't want to just plug those in. We want to get where is it coming from and where is it moving to. We're going to break those values. And since this is Y, we want to negative minus those. Then we're going to do absolute. So this way it doesn't matter which one we plug in to where, because it's always going to give us a positive value. Even if this returns negative, absolute will make it positive. We then want to minus 1. Oh. So integer minus 1. And then we want to do a for loop. Straighten that off. Plug that in. There we go. Then on the for loop, we want to get our from. We're going to break that again. We are going to add Y. And we're going to add our index. And then we're going to make int vector plug these in. And then we're going to have a new local variable. So add a local variable. We're going to call this tiles. It will be of type int vector. And it will be an array. We're going to get tiles, and we're going to add tile. So what this is doing is it's getting the distance between our 2 points. If we go back here, it's getting this distance. And if that is 3, it is going to 3 times add to our endpoint. So if that is 3, it's going to do, okay, 1, 2, and 3 tiles there to make up a corridor between the rooms. And that's why we always need to be moving, be very sure where we're moving from and where we're moving to, that we're always moving in a positive value. Okay, so that's why from A to B or B to A is very important, and why I'm putting that right in the comments, because then we can just, oh, I need a Y, okay? And from and to, plug those in, done. I get my tiles out. Speaking of getting tiles out, we're going to click on our function, add an output, and we're going to call this floor tiles. And that will be of a type array. So that when it's done looping through and adding things, it's going to output that full list of. And there we go. Compile and save. Then if we go back to our corridors, make map corridors. We're not going to do anything there yet, actually, because we're going to corridor make Y. We're going to duplicate and call this corridor make X. And in corridor make X, our minuses, we're just going to move from from Y to X. And our plus here, we're just going to move up to the X. You could make this one function or one macro and use a Boolean to select X or Y. But for simplicity's sake, I am going to keep them as two separate functions. Okay, so now if we go back to our map corridors, we're going from A to B on the y-axis. We want a corridor, make Y. And sorry, I'm just going back to my references here. Yeah. So corridor make Y, and we want to go from A to B. We're just going to go to our local variables and bring out a point A and a point B. Beautiful. Now we'll plug that in. And then we're going to promote this to a new local variable. And we're going to call this tiles. I'm going to straighten all these up. Here. We're then going to copy that, Control C, Control V, bring it down to our next area. And this is still on the Y, Y-axis, so we've got our corridor make Y. And from B to A. From B to A, we'll just switch those about. Oops. There we are. Then we want A to B and B to A on our x-axis. So I'm just gonna copy those bits and bring in one of our make Y or make X functions. So A to B, from A to B, and then add in our tiles. So not super difficult, just a lot of logical, okay, which side do I have to come from the room? That's why drawing it out can be so helpful when dealing with procedural stuff like this. I'm gonna copy paste that. Put it on in there, and we are going from B to A. We're just gonna confirm that. Make corridor from B to A. I'm gonna make those boxes a little bit. There we go. Cool. So now what we're going to do is we're going to take what we have. We're going to shuffle it down a bit. And after we get our corners, we're going to do a sequence. The first thing in our sequence, come on, right? Why can't I right click on there to straighten? Damn it, I'll right click over here to straighten then. Fine, be that way. So after we've checked our rooms, we then need to output our floor tiles. So we're gonna do an output floor tiles, and that is an int vector array, and we're gonna put in our tiles. All right, like that. Okay, you could copy this and put it on the end of each of these instead. I just like having it in one place. And the reason we're not directly outputting two tiles in the function or even directly out to the floor, is we're going to want to keep the floor of the room separate from the corridors for testing some other stuff. So actually we're going to rename this, instead of floor tiles, we want to call this corridor tiles or hallway tiles or whatever. And this should give us X to Y. We compile and save. It's going to show nothing different yet. But if we go to our spawn tiles, and before all this, before we get here, we are going to append array, and we get our floor tiles, and we duplicate for floor tiles, and we call this corridor tiles. And we want to append that to our floor. Okay, now we're going to go back to our event graph, and where we're making our room, so find location to put the next room. Before we set next location to previous location, we want to map corridors. So our room A is going to be our previous location. Our room B is going to be our next location. And they've been already saved to the rooms map. Then we want to get corridor tiles and append. And the reason we're keeping these separate from the floor tiles is that for handling the logic of spawning doorways. So if you didn't care about doorways, you could plug this straight into your floor tiles. But I want to have like doorways or archways heading into the corridors. So because of that, I need to keep the corridors and the floors separate, at least for a period of time. So this here, we're going to say, grab it and make corridor between last two rooms. And then update location for next loop. Lots of arrays and lots of looping. Okay. Now, if we compile and we save... Oh, okay. I thought I was gonna have an infinite loop problem somewhere. We get this. And we get that. And we get those. So, why? Why are we getting those? So it looks like those ones are connecting properly, and those ones are connecting properly. Why are we getting things off like this? Where did I screw up? The corridors. AX and X2, AY and Y2. Oh, we want to... Yeah, we're doing out X based on the Y stuff. I'm just going to take a quick look at my reference. So our room's parallel on Y. Y max, Y2's mins, less than or equal. BX AX for whether or not it is forward. X versus A2 and AX versus B2 to see if they're not merging. Yeah, all that is. And which direction is this working on? So this is just going on the Y. We are getting some on the X. They're just not going to any rooms. Okay. Are we getting weird lengths here? Maybe? Okay. So, making on the x-axis. AX with the Y in there. Or AX2 and AX. BX and BX2. Yes. Going out on the x-axis, making things. Going out on the y-axis, making things. Let's make sure that our y-axis is adding to the y. Yes. And our x-axis is adding to the x. Yes. The corridors look right. So what I'm gonna want to do is on our make corners, going to do a, not a print string, a debug point. So draw a debug point, or actually let's draw a debug sphere or cube. Draw a debug box. Sure. The center of the box is going to be our information here. So we want room A. We want 2 vector. Making that a vector. We want to multiply our vector by a float. And that's going to be our scale. And that's going to be our center. And then we want the extents to be 20 by 20 by 20. Thickness, line thickness of 5 maybe, duration 500, line color hideous pink. Then we're going to copy that, Control C, Control V. And instead of that, we want the extents, what we found there, and we want to set this to blue. Okay. So the root is pink, the far extent is blue. C, and this is debug room A. And then I want to copy all that for debug room B. And instead of pink, I'm going to use yellow. And instead of blue, I'm going to use a dark green. And again, I want the root location, and then I want the extents location. And I want those to run in parallel, or in series, sorry. And then go there, and go there. And then what we want on our event graph is before anything else, we want to flush debug lines. So it clears it every time. So if we compile and save, the debug lines are too small to be useful. Okay. So we're going to go back to our map corridors and back to our get corners. And the size of these, the extents, we're going to set more to like 50. Can I just like copy that? No. No, of course not. That would make it too easy. And then line thickness of 10. We want these very visible. Compile, save, and then we need to set this location, the location of our actor, to 0, 0, 0. Come on, where is just location settings? Really? You're not going to give me that information? It's way up there. Maps. Nope. Come on. So I want VP Dungeon, yes. Why won't you let me set your location? I just want your location to be 0, 0, 0. Why are you being a pain in my butt? So transform, there we go. And if I reset transform to 0, 0, 0. So here is our issue. So we're getting pink here, blue here. Pink here, blue here. I am not seeing any greens. Where's our room B? I've got a lot of pink. Oh, there's our green. So yellow, green, okay. But where's our blue one for that guy? Our blue one's way the hell over there. Okay, so our extents are not calculating properly. So our root corner should always be this corner, which the root corner seems fine. Yeah, root corners are fine. But the extents are behind the roots. Yeah, the extents are all off. Okay. So we need to go to our make room floor area and find where we are. Okay, so connected tiles. Okay, we're getting our connected tiles. We're getting all of them. We're adding to X and adding to Y. We're getting X, the max value of it, and Y. Oh, Y we're getting the index. Y we want the max value. So I just plugged in the wrong pin there. And now we've got corner and corner, 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 corner. Now things are looking good and we don't have random hallways shooting off to the sides. Beautiful. Okay. And anything that is joined left to right or forward to back is getting hallways built in between them. So now we need to do other things. Okay. So now we need to do corners. Corners, corners, corners. Okay. So I'm ready to do what we just did 8 more times. Yay! And I am not exaggerating with that either. Okay, so we're gonna go back to our map corridors. We're gonna go into our corners. We're gonna bypass our debug. Now that that all looks good. I'm tempted to delete it now. We shouldn't need it again, but I'm just gonna leave it there just in case. Always come back and clean it up later. I'm just gonna leave myself a note. So I'm gonna hit C out here. Remove debug in get corners graph. And we're gonna change that to a red color. So it's like, hey, pay attention to me. Okay. Compile, save. Oh, something we're gonna go out and look at on our map first. This map is good. Okay, so let's do a new seed. There we go. That's what I'm looking for. Okay. So you can see on these rooms, we are getting the extents. So here would be one corner, here would be one corner. We're getting that rectangular extents. But then when we go to draw a hallway to it, because we're dropping tiles out, we can hit something like that where there's a missing tile. Or over here. So what we want to do is make sure that these values are valid. So let's go do that first. So we're gonna move this down a bit. And we're just going to get point A, get point B. I'm gonna move these down a little bit further. And then we are going to contains array, contains item. And the array we want to put in is floor tiles. So that is the floor tiles global array. We want to make sure that where we're trying to place our endpoint, there is a valid tile. You're going to do an AND to make sure both of them are valid. Branch. And there we go. Gonna do a comment here of confirm endpoints are valid. We are also going to do a loop check here, just so that we don't run into infinite loop problems. So on false, so if these are not valid, we want to have a new variable for loop count. It will be a single variable and it will be an integer. And we're going to get loop counts. We are going to increment, so add 1 to it. And then we're going to check if it is less than or equal to max loops. And then we need another branch. And on false, we're going to print corridor failed. We're not actually handling this nicely yet, like we do for the finding endpoints, which goes back to a branching path. This one we're just getting, oh, this corridor failed to make. Okay, so corridor failed. However, if that is true, we want to come all the way back to our random right there. And then we need to, oh, we're going to turn bubbles off on this before copying it. Control C, Control V. And just paste this into each of those. And we'll see if this solves our problem. Oh, apparently the comments don't keep whether or not the show bubble is true. We're just going to turn that off on all of them by selecting them all there. Okay. And then we want on our lower branch to plug that into our getting of a random value on each of them. There we go. Now if we compile, save, we should see that none of them hit dead ends. Did any of them fail? No. Okay, let's try generating a new map. So select our map, we're going to say new seed, and it generates, and we are not getting a failed generation. Cool. Ooh. So I wonder where this one's generating from. So this room must go to like this room. That then goes to this room, which goes to this room, but I don't know where this room's coming from. It might be over here, or it might be over here. Yeah. It'll be interesting to see how those all connect. Okay. Speaking of which, now we can go do corners. Just before that, I am going to take a brief, actually, where are we in the video? We are an hour and a half in. Okay, so we've got half of our corridors done. We're going to call this it for part 2, and we'll be back in part 3 to make our corner hallways. Yay! Exasperated yay, because like that's the most tedious part of this whole system. Yeah, for now, you've got something where you can be like, hey, I don't want to call any floor things. So I can just have square rooms. Or I do want to call floor tiles. Or I don't want rooms to merge into each other to become big rooms. So it redoes them. Or instead of 20 rooms, I want 80. How long is this going to freeze up for? Did I just break it going too high? Too soon? Nope, there we go. Didn't take that long. Did it give me any infinite loop errors? It did not. Beautiful. So we can generate 80 tiles easy enough. And we've got some corridors going between them. If we were to say generate 80 tiles and allow branching and branching threshold at 10 rooms with a 50% chance to branch, turn on branching, we should get a little bit different thing once it generates those 80 rooms. Ooh. Okay. Why doesn't branching work? Let's go look at that. Go to our event graph. So branching goes through... Oh! Am I allowed to branch? If false, we need to come down here. That was a me being stupid. Okay. Compiling. Waiting. There we go. And we'll save it. And that will give us something like that, where rooms branch off each other. Yeah. So we get some fair size rooms, and we get some hallways going from room to room. We'd be like, oh, I gotta go that away. Gonna turn down our fly speed so we can be like, playing a game through random corridors. Be like, oh, which way do I have to go to get to the end? Oh, am I back in the same room? I am in the same room. And that's a dead end there. But yeah, it won't be once we get the corner rooms. Yeah, like look at this section here. We've got this whole Yeah. So we're gonna put this back down to like 10 rooms and get a new seed and turn branching off. And there we go. But yeah, if you're generating reasonable numbers of rooms, like say 30, it all goes pretty quick. You can generate quite a few different dungeons. Yeah. Ooh, that's a funky looking room there. Look at that one. And if you didn't want stuff like that, you could then turn your culling down to like, okay, maybe I only want a maximum of 3 tiles cut out per floor. And then I won't get funny looking staggered edges like that. But you'll still get some columns and cutouts and stuff like that. Yeah. So anywho, that's it for this video, and we'll be back next time. Well, for me, that's going to be like in 15 minutes here after I grab water and hit the washroom. But we'll be back in part 3 to do corridors that branch off to corners. See you then.